Today we're going to tackle one of the most common related rates problems in calculus, the cone. What we have going on is sand's falling off a conveyor belt at a rate of 12 cubic meters per minute, forming a conical pile. The height of the pile is always 1/4 the base. How fast is the height changing when the height is 3 meters? The first thing you want to do when approaching these problems, read it once, twice, 3 times if you have to. You want to make sure you identify the variables correctly, what you're given, what you want to find. Okay, so let's start with that. We are given a rate. This right here is dV dt. Now, how do I know that? Well, we're talking about a cone, but the units. Volume is always cubic, so that's a clear indicator that this problem gives us dV dt. We also know the height is 3, but the thing we want to find is how fast the height is changing. So that is dH dt. That's going to be the rate I'm looking for in this problem. Now, since we have a cone and we are given volume, we want the volume of a cone. That's the equation we're going to use, which is 1/3 pi r squared h. And then we're going to start taking the derivative. Now, here's the problem. Related rates are basically story problems involving implicit differentiation. If we take the derivative of this equation, we're going to get 3 rates: dV dt, dr dt, and dH dt. Well, we're only given one, and we want to find dH dt. So we have no idea or want to find dr dt. We need to get rid of it. The nice thing about cones is the height and the radius are always going to be proportionate. So we know the height is always 1/4 the base. Well, the base is also known as the diameter. So we know that this bottom piece is d, and the height is always 1/4 the diameter. Well, again, that doesn't have r in it, but hopefully we know that the diameter is also 2 times the radius. So a little bit of simplifying, and we know that h is 1/2 r. And we're going to make a substitution into our equation because we want to get rid of r. If we get rid of r, we will not have a dr dt when we take the derivative. So that means I need to solve for r. So r is 2h, and now I'm going to substitute that into my equation. So I have volume equals 1/3 pi times the radius is 2h, and I'm squaring that. So if I simplify this, I'm going to get volume equals 2 squared is 4 times 1/3 is 4/3 pi. And then I have 3 h's. H squared times h is going to give me h cubed. And this is where I'm going to take the derivative. But before I do that, let's talk about some things. I see a lot of mistakes when approaching these problems. I have students who like to take these numbers and just start plugging them into the equation. Well, first of all, this is a rate. This is not the actual volume, so I can't even plug it in for V. Another mistake I see students often plug this height in the equation before we do anything. Now let's think about the problem. We have sand falling off a conveyor belt. So this pile is going to be growing. The height, radius, diameter, volume, whatever variable is always going to be changing. Since they're changing, we cannot plug anything in. The only time in a related rates problem where we can plug something in before we take the derivative is when it's constant. And we don't have that here. So, back to the problem. Let's take the derivative now. The volume is going to go to dV dt. The constant rule, 4/3 pi is a constant, so we're just going to drop it. H cubed will go to 3h squared dH dt. And now I have everything but dH dt, and now I'm just going to plug everything in. I know dV dt is 12. I know my height is 3, so I'm going to plug that in for h. And now I have everything but dH dt, so I can solve for dH dt, and we're about done. So we can simplify a little bit. These 3's will cancel. So I'm going to have 12 equals 3 squared is 9 times 4 is 36 pi. And then dH dt is going to be 12 divided by 36 pi, which will reduce to 1 over 3 pi. Now, my units. It's easy to forget the units on our answer. We're talking about height. It's a rate, so we need this per minute, similar to our dV/dt, but we're not going to be talking about meters cubed. It's just going to be meters. Now we're done. Designated Deriver here to help you out with all of your math questions. If you thought this video was helpful today, please hit that like button. Subscribe if you haven't already. Any questions or suggestions you have for future problems, leave them in the comments below. Thanks for watching.